We're trying to change a paradigm that has never been tackled before. We're trying to take the vision, space visionaries and make realities for them, turn vision into substance for the next generation. You played with Legos, hopefully, as a kid, so it'll be easy to understand. When you used Legos, you didn't think about anything about the Lego itself, whether it was plastic or the little bumps. You just put it together and built what you wanted. Okay. That's what we've tried to put a technology together for space. Right now, space is restricted to governments, NASA, billionaires, however you want to look at it. It's not the general public. We've tried to make a Lego for you and for me and the next generations that's going to come to work in space with almost not having to spend the dollars, the resources, the pain, and the problems of working in space. We call them hyper-integrated satellites, small satellites in a box. Hyper-integrated. Everything you need to have in space is in that box. So you don't have to worry about it. Like you didn't worry about your Legos, they were made of plastic and had knobs. Everything it will control, it handles the environment. It stays in orbit. It does the station keeping. It has a robotic piece to it. It can connect, it can disconnect, it can reconfigure. It's software defined. You don't worry about it. It's one box and it's replicated. It's the same Lego block, HISat we call it, over and over and over. Why? Because it's cheap. They're all the same size. The current versions are 4 inches by 8 inches by 8 inches. All the power needs, the solar, propulsion, metrology, so it can sense its environment, communication, so it can talk to the pieces. It has processing, it has storage, it has motors that you can put together so that you can make different things. You might want to make a robot with those motors. You might want to use those motors to control your attitude. You might want to use those motors to point a reflector, to steer a telescope, to point a reflector dish for communications to deep space. If I were to build a habitat, I might want to use that to operate the clean water system, the clean air system. It's a general purpose brick, as you call it, what we call a hyper-integrated satellite, that you get to software define to do what you need. It takes care of all the space problems. You just tell it what you want it to do. We could build space dock. We could use these Legos, build a space dock. And then inside that, we could have people build our favorite craft. Another example, we could assemble them to make a large solar collector. We could have power plants in space. We could have multiple power plants. That's another use of them. Very simple. Doesn't take all the effort of the current systems and the cost to make a large solar plant in space. My favorite right now, we're working with Air Shepherd. They're a program that terrestrially is taking drones and trying to protect elephants from poachers. We could put up systems where you and I can say, I want to also join in. We'll put up a monitoring satellite, and in our spare time, we'll monitor the wetlands and the grasslands of Africa. And if we see poachers, we'll type it on the internet. We'll police. The world can start policing and tracking and taking care of our environment. We can assemble in weeks, put together your favorite dream in months, and then go to these new launch services and start protecting, analyzing, utilizing space in a way we've never been able to, in a speed and cost we've never been able to. One of the things we've done to demonstrate how you assemble it, we've sent up these pieces to the space station. The astronauts are looking forward to assembling a spacecraft and literally sending it on its way. The first example of how you can build things in space. They're going to be our first examples. Different uses. There are entrepreneurs that have already figured out how to self-assemble them. There are those that want to use robots to assemble them. There's one entrepreneur that already has a design that puts them together, and it's itself its own robot. We really have a lot of different thinkers who are starting to say, what if I could do what I could dream of in space myself? It's the adventure. It's the next generations. And we're business tackling the next generation and what they can do. So where do we start? We start educating. We start letting people know. We start letting people understand they can be involved in ways that they've left alone. They can join in the monitoring of the planet. They can join in the care of the next generations of our oceans, our land masses. This is an opportunity that NovaWurks wants to give everyone to think about space in a way they've never thought about. And there's the challenge we want to leave with people, is if you have an idea, we can make it happen. And we want to go down that path together.